Good morning, everyone, and welcome to this morning's webinar on new CNC options. Basically what we're going to be covering this morning. I'm just going to do a quick overview for everybody on the DSTV standard. I know a lot of you may be familiar with this, already know this stuff. Some of the presentations that I've been in seem kind of confusing to me, and I think a lot of people still don't quite understand some of the information within DSTV standard and how that works. So I've laid it out a little differently this morning to kind of go over that quickly with everybody. And then, like I said, what we're going to focus on after that is going to be newer options to our DSTV, the CNC download. Not going to cover everything, just want to get people more familiar with some of the newer options and how the 7.3 options are laid out a little differently than they were in 7.2. They're just organized a little differently. And then we'll just briefly touch on the XML CNC download at the end of all of that. So, like I said, what I first want to start off with is kind of describing the DSTV standard a little bit, explaining some different things to everybody. So what I've done here is I actually have just a sample DSTV file that I have open here, and what I've done is all of my text in red are the comments that I have actually added manually myself after I've downloaded this file from SDS2. So the comments in red are going to kind of explain the information within this file for us. So couple things here before we actually dive into that. One of the things with DSTV, or a couple things with DSTV, is this is only describing the final geometry of our steel. It doesn't describe any tooling information, whether a machine is to drill a hole or punch a hole or burn a hole. That's all left up to the controlling software. This just defines the geometry of the material. The other thing to note about the DSTV is it has to, when we create the information, we kind of have to assume ideal steel, that it's always a certain depth and always has the same flange thickness, so on and so forth, when that's really not always the case. But this does assume that, and then again, the machinery or the controlling software should account for this when the file is imported, when that piece is actually run through the machine. So first thing we're going to see in our DSTV files, this little ST at the top just indicates the start of our file, and then the information that I have highlighted here, that would be considered what we call header information. So starting up here at the top, we're going to see first off our drawing or the sheet for this piece. We're going to see the sequence. We have the piece mark. We have the grade, the quantity. We have section size, our profile, and that profile is going to be different depending on the material. For angle, we could have a different one, channel, so on and so forth. Next we have our length, and I've kind of commented it out here as length and then a comma and saw length. So if our final length may be different than saw length, we could see over here a comma with the saw length after that, and I will touch on the difference between those here in a minute. The next we have is our depth, so that's going to be the total depth of the piece. You have your flange width, flange thickness. We have the web thickness, the radius, not necessarily the K distance, but the actual radius of the material inside where your flange meets the web. Our weight, and that is actually in kilograms per meter. We have surface area. At this time, SDS2 typically doesn't fill out the surface area, but it is a field in there. You have your web start miter, web end miter. So if we have a miter cut on either end of the web, so the start would be typically the left end, the end miter would typically be a web miter on the right end. And then same thing, we have a flange miter and a flange end miter. Again, start is typically on the left end is typically on the right end. And going through some of these values, you're going to notice just like the depth and the width and everything here, this is actually always going to be in millimeters. So it's all the information is actually going to be metric in millimeters. Not a way to change that. That's what we'll always see in there. So one thing to take note of there. Now, after our header information, our information is going to be grouped in what we call blocks. And a block is identified just by two letters here. In this case, we can see this first block is started with an SI. And just to quickly cover the different blocks that we might see in there, first one would be SI. That's basically just text stenciling. The next one we're going to see would be a BO. That actually is going to indicate a hole block, so the start of holes. AK block is going to be what we call external or the outside contours of the material. IK is going to be internal or inside contours, might be things like web openings. We might see a PU block, and that's going to be what we call a powdering block. We may also see a KO block, which indicates a marks block. Typically, if you have like scribing for outline of materials, most typically you're probably going to see that in a KO block. So that's just a quick rundown of the different blocks we might see. Now going back to our file here, first off we have a SI, so this indicates this is the beginning of a text stenciling block. And then we have additional information down below that. First thing we have is the face. So each face is just indicated with different letters. And what you're going to see there for the different letters to indicate faces. If we see an O, that would be on the top flange. A V would be the web near side. U is going to be on the bottom flange. And an H would indicate the web far side. So in this particular case, we have a text stenciling block. That's going to be on the V face or web near side. We have our X distance indicated from the left end. We have our Y distance indicated from the left end. And now something to take note of here with the Y distance also, if I take a look at some information from our DSTV standard, we have indicated here all our faces and whatnot. So looking up just here at our wide flange piece, I said the U face is going to be the bottom flange, so we can see indicated here U is pointing to our bottom flange. This NP indicates our work point, and that is always going to be our work point. So if that's the case, the Y distance is always going to be taken from the bottom of our steel rather than the top of the steel. So that's our Y distance. We have the angle of rotation of our text. So right now it's just 0. It's going to be parallel with the length of the piece. We could do 90. It would be perpendicular. You have the text height, and then you actually have the text string that is to be stenciled there as well. So that's an SI block. Next thing we see in here would be KO. Again, that's just the beginning of a mark or a stencil, typically for like an outline of a piece or something. Again, you have your face indicated. You have the X distance, the Y distance, and then an angle here as well. Have a few more KO blocks, another SI block. This one's indicating a P1, so that kind of shows me that it's for piece mark of an attached material. Next we have a BO. So if you remember, I said BO would be a hole block. So it's beginning of a hole block. Again, we have the face this is on. So this one is actually O. That indicates the top flange. You have your X distance, Y distance, and then the diameter of that hole. This is just a standard round hole there. We have another BO or hole block here. Again, we have a face. So again, this is on the top flange. You have your X distance, the Y distance, and now we have an additional few fields here. Next field we have there indicates to us a slot, and the way that indicates to us that that's a slot is just the L that I have highlighted there at the end. So when we see that, indicates a slot. We have the width of that slot, the height of that, that's typically just the same as the diameter, and then the angle of that. So is it 0, is it 90? Then we have a few more BO blocks or hole blocks, and finally we get to an AK block. Again, that is an external or outside contour block, and essentially all that's happening here with this, you're going to see this is listed on the O face, so this is just defining the external contour of the top flange, and we're just defining points of the outline of that piece. So you have your X distance, your Y distance, and then if there was anything that was radiused, you may see that here in the third row. One thing you will notice with the AK blocks, typically the first point is always going to equal the last point. Since it's a contour or the outline of a piece, it always has to come back and make a closed shape. Next you have your IK block, and this indicates to us a internal contour. Like I said, could be things like web openings. In this case, that is what it is. Again, it's similar to the AK contour. We just have the face that's on, then the coordinates for the outline of that piece. Here you can see with the radius, we do have some corners where it is radiused. Again, the first point that is specified typically equals the last point that is specified, so we get a closed shape. And then we have another AK block. This one's showing us on the V face, so that's defining the web. And we have a third AK block for the bottom flange. Again, you have your X and Y distance, your radius, and then the two numbers here at the end actually indicate or define some sort of end prep. In this particular case, when I open up the file and show you, you'll see we have like some end preps for welds or whatnot on the flanges. And then at the end of the file, you're going to see an EN, which indicates the end of a file. So just quickly kind of go over the information and how it's laid out there in the DSTV format. Now, if we take a look at this file in a DSTV viewer, which I'm going to do here, and I have ATEC Automation's viewer. It's easy to use, works really well, so that's what I'm going to be using for most of my demo today here. But what we see here is we just see this piece imported into ATEC Automation's viewer. This is what it interpreted from that DSTV file that we just covered there. So we can see that internal contour that I talked about having here. You can see how the corners on that are radiused. We have some marks there. We have a piece mark there called out for our plate. We have a piece mark here. If I look at a little better view of the web, we can see the weld preps that I talked about having in there. So this just kind of gives us a good visual rather than just looking at the DSTV information. Okay, so that's kind of just a rundown, like I said, quickly of kind of the DSTV format, how that information is laid out. So the next thing that we're going to go ahead and do is we're going to actually open up some of our CNC options and take a look in there. So from the main menu here, I do want to point out I am using version 7.3.1.6. That's our latest beta release. Most of the options that we're going to be covering should be available in 7.3.1.2 or 3.1.3. So when I open CNC, Okay, first thing I'm going to have in here is my configuration and my CNC type. Now, one thing I do want to point out is straight out of the box, SDS2 provides you with several configurations, and if I wanted to change my configuration or see all the ones that are available, I'm going to select the file cabinet on the right here, and what we include out of the box are going to be just a regular DSTV. We have a DSTV, Python X, Control Automation, Petting House, and Steel Projects. So just straight out of the box, these are all set up a little differently with different options based on some experiences and some of our knowledge to work well with those machines. Now, that being said, not every machine can be set up the same in everyone's shop. There are also possibly conflicting options in our software versus the controlling software because they have an array of options to account for certain things as well. Sometimes they kind of counteract each other. So, like I said, with some of our experiences, these should work well out of the box, but may not be perfect based on your setup with how everything's laid out in your shop, what options are checked in the controlling software. Okay. I've actually created a new configuration for our purposes so that I don't mess with any of these other ones. So I've just created a DSTV modified configuration. Now I'm going to go ahead and go into the setup. And a few things that I want to cover here. Most of this is not necessarily very new, but it is something that comes up a lot with us here in support, so I want to cover it briefly. First thing is our machine limits over here. So basically with those options, we're just specifying the minimum and maximum material lengths, depths, maximum flange thickness, maximum web thickness that can be run through our machine. If that material is outside those ranges, SDS2 won't download that material. Our hole fabrication limits then down here below that, these are going to actually control minimum and maximum allowable hole sizes, minimum hole-to-hole edge distances, hole-to-material edge distance, hole-to-radius, and then finally that one on the bottom, the maximum amount of punch overrun. The maximum amount of punch overrun may be kind of a little dated option, probably for older machines or machines that are still punching the holes through the material. What this option is there for is this is to limit the size of hole that's downloaded. So basically, let's say we have a 16th set in here for the maximum amount of punch overrun. If we have material that's a 1/2 inch and 16th is input here, SDS2 won't download a hole whose diameter is smaller than 7/16 in that material. So prevents holes that are smaller than the thickness of the material from being punched. Like I said, typically for a machine that's going to punch the holes. So with the drills and burning and everything, a lot of times we can kind of ignore that option. Another thing to note about these options here, the minimum hole clearance options here, those are not actually taken from the center of our holes. Those are actually taken from the outer edge of our holes to whether it be hole to hole or hole to material. So a little different than what we might typically be used to. You know, you're always referencing the hole center usually. This is the edge of our holes. So one thing I always run into quite a bit with our hole fabrication limits is I always get calls, someone downloaded a piece of material, sent it out to the shop, and shop calls back, there's holes missing, or that hole is just a mark there, and they need that hole to be burned. Okay. Two options on the left that can help us with that. We have download holes outside diameter range as, and download holes too close to edge, web, flange, bender, and other hole as. By default, these are set to a mark. So what that means is if any hole falls outside of our limits that we have set here, when we download our material, SDS2 is just going to place a little hole mark there, basically a 0 diameter hole, so that the machine would just put a little mark on there. Well, that's not always necessarily really helpful. What most people, I find, want to do is set those options to fail hole print report. That way when you download this piece, you get a printout on your screen. SDS2 pops up the output request viewer, and it gives you information about the hole that's outside that limit and gives you the reason at the end, basically which hole fabrication limit it's not meeting. Then we can take a look at that. We can make adjustments and re-download if necessary. So something that I run into quite a bit there. Starting back up here then at the top, at the left, I'm not going to cover all these options, just a few here that we get questions on quite a bit and can be helpful. So the first one there, disable error checking, that completely disables any checking of the machine or the hole fabrication limits, just basically ignores all that. We'll download everything. Our batch download, I'll come back to this a little bit later, but essentially what that does is it groups your files in different folders based on the holes that are required to be created in each face or each surface. The download plain members, no holes or marks. So what that does is if there's no holes or marks in a piece and this is not checked, SDS2 will not download the information for that. If we still want to run our pieces through, maybe there's copes and things that still need to be cut out of this piece, and we have a coping machine, or we want to run it through a Python X machine to make those cuts, we could go ahead and check that, and even though there's no holes or marks, we'll still get that piece downloaded then. Include attached submaterial and member download. This will actually, when we select, say we select a B1 from our model to download the CNC information, all the plates, angles, whatever material is actually to be attached with that piece will be downloaded at the same time. The next thing that I want to point out here is down here, our CNC piece quantity. We have an option there for either the quantity in job or the quantity in selection. So if this is set to job, no matter how we select our pieces, whether that be from just a selection list or we select the pieces in the model, the quantity indicated in our DSTV file should be the total quantity required for the job. If we set this to selection, what can be done is when you select pieces from the model, if there's, say, 5 B1s in the model and I only select one B1, the quantity in my DSTV file would just indicate 1 because that's what I had selected. So we can get different quantities based on that. The next one, use dimensions from, we can specify either a final length or a saw length. So a lot of times this will come into play with sloping members, or we see it with stairs a lot. And essentially what the difference is between those, saw length is actually kind of a theoretical point out in space that we would need that material length to be. So we can see the dimensioning here is out in space a little bit, like I said, kind of a theoretical point. The final length is actually the end of our material after those cuts have been made. Some shops do it a little bit differently. Some prefer the saw length, others prefer the final length, so whatever we're requiring there. And then finally down here at the bottom, your material types. This will actually limit the material types that get downloaded with this configuration. So maybe with this configuration I didn't want any plates or cold formed materials downloaded. I can go ahead and uncheck those, and SDS2 will refuse to download these materials of that type with this configuration. So just kind of a quick rundown. Like I said, I'm not covering everything, just some of the newer things and some of the areas where we get a lot of feedback from or questions on, troubles with, I guess. So next thing, I want to go into options, and you'll notice, especially for those of you who might still be in 7.2, haven't made that jump yet, 7.3 is laid out quite a bit differently with our options. Basically what we did is we took generic DSTV options, we put that under a general tab. Anything to do with scribing, we made a scribing tab and placed that within the scribing tab. So some of the new options in here, one of them is going to be prefer putting slots on the O or U face. This typically applies to angles. So basically what's going to happen is if we look back at this illustration, our angles here, with this option off, SDS2 will go ahead and download this file with the long leg horizontal like we see here. O and U faces are going to be in our short leg. If we turn that option on, it's essentially going to flip those legs, and then your O and U face would actually be in the long leg of the angle instead of the short leg of the angle. Okay, the next option that we have is going to be split files. So I'll get quite a few questions on this. This is something that's fairly new. So if we have this set to none, B1 is always going to be downloaded in one file. If we have this set to scribing and I have several B1s in the project, and the scribing on those could be a little bit different, then SDS2 will go ahead and create separate files for each one that needs a little bit different scribing on it. We could do this by sequence, or we could split by both sequence and scribing. So just as an example, if I set this to scribing and I download a piece from my model, typically, you're going to need this or see this when you're selecting by submaterial. I have a W14 in my model. Just to show you here real quick, I have two W14s here. The only difference is my shear plates here have a little different piece mark. So when I go to download this piece, that W14, and I look at the directory where this is downloaded, notice I have two pieces, both called W14.0, W14.1. That indicates to me it has different files. I get a text file created, and this just tells me which member number is for which piece. So going back in there then, that's our split files. Another thing that's new is with the file extensions, the .dat in here is new. We've had the options of NC and NC1 for quite some time already. Going over here to the right, one of the new things over here would be the to omit order length in section sizes for plates. So typically, if this option is off, you're going to see a plate description, something like PL 3/8 by 6. If we have this option turned on in the DSTV file, we're just going to see a plate description of PL 3/8. It leaves off the 6 then. So again, just to remind you, a lot of these options are for specific machines. Could be because your shop is laid out a little differently, but you also need to keep in mind that a lot of these options can also be in the controlling software, and I have ran into several situations where they kind of counteract one another. So just be aware of the options available here as well as in your controlling software so that you don't run into problems where we're counteracting each other. That's really the new options within this general tab. Next thing I'll look at then is going to be under the scribing tab. Again, laid out a little bit differently. So I'm going to come in here and let's say I want to choose to do the placement options for submaterial. This is going to be for the outline of our attached materials. We can choose to do the outline or the marks for all material that's welded or both bolted and welded material. I'm going to go ahead and leave it at welded here for now. Another thing that you're going to notice is different is the scribe type. So in the past, the scribe type was actually asking for the block type that you wanted this to be placed on, and it would say KO, PU, or BO. Now, we confused a lot of people with that. They didn't understand what the different blocks are, so we tried to put it in terms that might be a little bit more easier for people to understand. So standard actually will put things in a KO block. This is going to be what most machines with scribing capability use. It's kind of the most typical. Powdering is going to put things in a PU block, or if our machine doesn't have true scribing capability, but we want it to put hole marks, like on the corners of our material, we can choose to do hole marks, and we'll get like a 0 diameter, just a pop mark there. You have your placement lines. You can do a whole outline. We can do just on the corners or dashed lines. I'm going to put this as an outline. Shear studs are something that's relatively new here. Again, we have our scribe type. So basically what's going to happen if we have shear studs and we choose to scribe them, we're just going to get a simple little L shape where that shear stud is to be placed. The size of the L shape depends on what we have set here. We can scribe that the diameter of the rod, or we can scribe that the diameter of the head of the shear stud. The next one we have here, hole matching marks. This is something that I've actually myself gotten quite a few requests for here in the just recently. So hole matching marks, what this is going to do is for materials that are welded to say for our beams, for example, or another material, for example, maybe we have a shear plate that's going to be welded to a beam. Okay, what the hole matching marks does for that when it's turned on is it goes ahead and scribes just a simple little line to indicate where the center of our holes will be, so that when they're assembling that piece in the shop, they can assemble that piece so that the centers of the holes line up and are placed where they actually need to be. Again, you can do that with a standard or powdering scribe. We can choose how long that line is, so the dash length is just the length of that line that we scribe. And then lines per hole group, if we have all checked, we're going to get a line scribed at the center of every hole in there, or maybe we just want to locate the top or the center of the top or first hole. I can put one in there, and then it will give me one line at the top or the first hole, and that's what I'm going to leave here to kind of demonstrate that. If you did two, so if you had two input here, you would get two lines, one at the top hole, one at the bottom hole. You could do three, and you'd get three, so on and so forth. Okay, placement piece marks are just used to scribe the placement piece marks to locate submaterials where they're located. You have a minimum distance to edge, so how far from the edge do we want to leave that piece mark? And you can still use this even if you're not doing the outline marks up here, so you could just have that turned on and just get the placement piece marks if you wanted, or vice versa too. Something new with the framing side mark, we can specify text and actually give it what character we want it to scribe there. Now, this can sometimes be limited by the controlling software, what the machine can do, so keep that in mind, might be a limitation there. Something else that's new, I guess, our center of mass has the same thing. Then another fairly new option in here would be the scribe copes. So if we have a machine that can't actually do our copes, but it can scribe, maybe we want it to outline or scribe the outline of that cope That way when it goes on to later on, we're going to actually have a person cut that cope or whatever. We know exactly where that's laid out. Saves time on laying that information out. Again, we have our scribe type, how we want that laid out. So something else that's fairly new there. And then finally, the scribing standard parts. If we have fused material in the model and we want that scribed on our materials, we can choose to scribe it similar to how we would submaterial. We can scribe it how we would do shear studs with just a simple L to indicate like the diameter of that piece. So, okay. So kind of quick rundown of some of those options. I'm going to download several pieces here that I have in this model just to kind of show you some of those options and what they actually do. The biggest one I want to focus on was that hole matching marks. What I'm going to do, however, with this is back in this main window, remember for my DSTV modified configuration, I checked include attached submaterial and member download. However, I unchecked all my plate options. Maybe I want those downloaded with a different CNC configuration with some different options checked for whatever reason. So maybe the fabricator I'm working with, maybe they have a machine that all their rolled sections can go through with DSTV. Maybe DXF plate has to be used because they have a specific plate burning machine that needs to use DXF plate. So what I can do here is come in here, set up my DXF plate to be the way I need. I'm going to just do this real quick. Like all I'm going to do in here is uncheck all the material types except for plates and flat bar. I'm going to also check include attached submaterial and member download for this piece. And then in my options, I'm just going to choose burn all holes and slots. Now, when I pick my configuration, I can actually pick multiple configurations in here. So I have DSTV modified and I have DXF plate. And when I go to download now, I'm just going to pick all the beams in this model. Say OK, and once it downloads these, I will get a little warning here. So it's telling me P2 disabled for this material type. So all those plates, I disabled that download for the DSTV, so it's just giving me that warning. And then the rest of them are for my DXF plate download. I disabled my rolled sections and my angles for the DXF plate download, so it's giving me a warning it didn't download those for that configuration. However, when I look in the folder where I downloaded that, notice I have two folders. I have one folder for my DSTV modified configuration. I have a folder for my DXF plate configuration. When I look in there, I have my plate DXF files here, and then I have my NC1 files there. So now, let's go ahead and just, I'll quickly open up the file that I just downloaded. And again, I'm going to open this with ATEC Automation's viewer. So when I go to open, and I come in here, grab my B1. Okay. Looks similar to what I had before. It is the same piece. One of the things I want to point out, like I said, this is something that I've had quite a few requests for. So I zoom into the placement for my shear plate. Notice I get that one little line that is perpendicular to the plate. That's indicating to me the the center of the first hole where that should be located on that piece. So helps with the layout of that out in the shop. Again, you had that web opening. I asked when I downloaded to have the outline of my piece scribed, the piece mark, we got that there. And then we get our copes and everything else in there as well. I did also turn on to place the piece mark of the actual shipping mark there, so I get that as well. So kind of just a quick rundown. One other thing I do want to point out, and I told you I'd come back to this, is that batch download option. So I'm going to go ahead and I'm going to actually get rid of some of these folders in here so we don't get confused. And I'm going to go back into my DSTV modified option. I'm going to go into setup, and I'm going to turn on batch download this time. So I'm going to also pick my DXF plate configuration, and I'm going to go ahead and download this. Just going to go ahead and pick everything in here, and it's not going to like me. Okay, well, it halfway worked. For some reason, my DXF plate didn't download. I'll have to look into that. But what we can see happen here is when we have batch download turned on, we get a folder with a configuration name. It gives us the date, so 0618, and then it actually gives us the time. So we have 11:10 there, and then it actually has seconds at the end. When we open that up, we're going to notice we have several folders in there, and within those folders we have our different DSTV files. So what it's done is it's grouped in folders based on the tools or the holes that are to be required in each face. If we open this master tools text file, okay, it gives us the path name, folder 1, and it tells us 1 in the top flange, the diameter, 2 top flange, another diameter, length, that one must be a slot, and then our tooling in the web. And then for folder number 2, this one just requires the one hole size in the web, so it's telling us what folders require what tooling. So we can send that out to the shop. They can run, folder 1 through with certain tooling, then they can change their tooling, do folder 2, so on and so forth. So just helps with those machines that we have to worry about changing the tooling on all the time. Okay. The last thing I want to cover is just real briefly our XML CNC download and some of the things that we could benefit with that. Just want to start off with this by saying this currently works only with Control Automation, their SciCam, and then the ATEC Automation viewer that I'm using can also import the XML. So those are the two at this time that work with that. And what this is going to do for us, we're going to actually download this from the model when we do this, and it's going to be by member. So if I select these members in the model, come up to my model pull down, I could come down to member and XML CNC download. Okay. This gives me options to generate one file for the whole selection. So one benefit over DSTV is we can create one file for our entire selection. We only have to transfer that one instead of having, hundreds of different files. We can have one file for each sequence. So if we selected members in 4 different sequences, we should get 4 files, one for each sequence. Or we can do it for each member as well. I'm just going to do this for the whole selection. If I check Generate PDF also, that's just going to create a 3D PDF file so I can use for reference. And Group by Sequence, that's different than the Generate one file for each sequence. Group by Sequence will actually work when I have whole selection selected here. It's going to group the parts in this XML file by their sequences. So I'm just going to do whole selection, generate PDF also, say OK. This one's going to actually ask me to create a name here, so we call it XML for webinar. I'll save this. Now when I open the folder I sent it to, I have the XML file here, I have the PDF file. If I just open this up quick like to show you, all it is just a 3D PDF, like I mentioned, just for reference. Maybe I need that for checking purposes. And I should be able to view that here. I'm using Bluebeam. Adobe Reader can view that as well. Okay. Now, just to open up this XML file quick and show you some of the information that's in there so we understand what's actually in this file, what we're going to see, some of the benefits to this that could be utilized. One thing that we're going to notice is we have our job custom properties listed up here at the top, so that could be included in there. And then this is going to be in order. We have assemblies, or assembly would be considered a member in SDS2. We have status information listed in here with that. Coordinates, we include a GUID, and then we have each part or each material that makes up that assembly listed here. The DSTV information for that material then is listed there as well. We have then also weld information. One of the big benefits here with the weld information that we have over DSTV is the weld information can indicate to us whether that's on like the bottom of our top flange or the top of our bottom flange, where DSTV currently does not have the capability of specifying those two surfaces. So we see here this weld is indicated the far side, top flange, underside. So another benefit we have there if we were to be using the XML. So now if I just go ahead and open this in the ATEC Automation, so I'll say open. I'm going to look for XML files. I have this XML right there that I created. One of the things that we see for that is we get our different Scribe options. Let's see if I go to, yep, so let's say for example I look at this B_4. Okay, it actually gives me or shows me the entire assembly information. This actually, using the XML, kind of leaves more of the scribing and placement of our piece mark and things, kind of leaves that more up to the controlling software, what would be done here. So we can see the scribing that gets there, the piece mark. This one we're actually seeing the weld called out there. The weld is an option with the DSTV. I just didn't have it turned on when I downloaded that piece before. So we can actually see the entire assembly when we import this. I can also expand that and see just my materials. So it'd be like your material versus members in SDS2. Same sort of concept, but then that gets rid of all the other materials from being displayed there. So that's just kind of a quick rundown of the XML download that we currently have. Like I said, currently, as far as I'm aware, the only ones that work with that currently are Control Automation, the SciCam, and then this ATEC Automation will also import that. So that's all I have here for everybody this morning. If you do have any questions that came up, anything specific you want to ask, please go ahead and email support@sds2.com, or if you got our number, you want to give us a call and chat about that, please feel free. I'll try and get back to anybody that has these CNC questions as soon as possible, so feel free. And I thank everybody for attending the webinar and hope you all have a good day.